Well, yeah, thank you very much for joining me on the podcast. It's definitely a bit of an honor to have you here. I'm pretty excited to jump into things. Well, I guess it would be nice for all the listeners just to find out a little bit more about you as an introduction. So could you try giving me your life story in 4 minutes?
My life story in 4 minutes. Sure, I can do that. It's 9:04. Okay, so, well, I started out growing up in London, and when I was about 9, I had a kind of revelation that has essentially guided everything since then. And it all came about because my mother had, for whatever reason, decided she wanted me to play the piano. And so I was being forced to practice the piano, and I didn't like this. And for some reason, I actually started to think about why I didn't want to practice the piano. And the fundamental answer that I came to was, well, it was simply because the best possible outcome of spending all this time doing this would be that I would become a good pianist. And I didn't think that that was much of a goal, because the fact is there were already lots of other good pianists, and therefore I wouldn't be kind of, significantly enhancing people's quality of life by becoming another one. And it was that led me over the years, over the next few years, to an increasingly concrete realization that I wanted to be a scientist, because ultimately I wanted to make a difference to the world. And I recognized that scientists in the long run make the most difference. So I went into computer science eventually. When I was 15, I started programming, found I was good at it. So I thought, well, okay, I'll go into that, because one of the big problems that the world has is the problem of work. The fact that people have to spend so much of their time doing stuff that they wouldn't do unless they were being paid for it. And so I'll stop that by helping in artificial intelligence research to create more automation. And I did that quite happily for a while. I did my undergrad degree in computer science at Cambridge, and worked in research in that area for several years. But during that time, I met and married a biologist, someone quite a lot older than me. She was already a senior professor in California, actually. She was in Cambridge on sabbatical initially. But through her, I not only learned a lot of biology, I also began gradually to realize that she wasn't interested in aging, and indeed nor were any other biologists that I was meeting. And I realized that that was extraordinary, because I had never thought that anybody would not think that aging was the world's most important problem. And the only reason I had not gone into it myself was because I didn't have any reason to believe that I was an exceptionally good biologist, whereas I did have reason to believe that I was a damn good programmer. But having found out that basically nobody was working on trying to keep people healthy late in life, not properly anyway, I thought, well, I better switch fields, really. And that's what led to my moving into the biology of aging. Back in the early 1990s, mid-1990s, which was when this was, I had actually had to shelve my artificial intelligence research because of lack of funding. And I had taken an extremely undemanding job at the University of Cambridge, a bioinformatics job, specifically in order to give myself enough spare time and access to resources so that I would be able to just do my research. To resume my artificial intelligence research. So that, of course, put me in an extremely helpful position in terms of switching careers. I could just create a whole new career for myself in my spare time without any risk, basically. And that's what happened. I was fortunate enough to have a few ideas in the late 90s that were quite well received. So I rose to a fair degree of prominence in gerontology very quickly. And then in the year 2000, I had the key idea of SENS, the idea that comprehensive damage repair is the most promising and practical way to actually keep people healthy late in life. And it took me several years after that to really get the community on side. At first, most people in the biology of aging found this idea very heretical, and even they didn't think of it as particularly scientific. So there was a great deal of education that I had to engage in to get people to understand the basis for why I was saying this. But that was eventually successful. So by the late 2000s, this had become, a reasonably accepted idea, and certainly by now, by the mid or late 2010s, it's totally mainstream and orthodox, and it's being reinvented by other people constantly. And I never have to actually persuade people that it's a good idea anymore. So that leaves me in the position I'm in. I've, of course, become fairly prominent in this field, and I am able to influence its direction quite a lot in terms of bringing money in, both from donors to the foundation and also from investors into startup companies. And that was 5 minutes.
Yeah, that's pretty interesting. I was like perfectly happy for you to carry on speaking. Really, I was like, oh, this is pretty nice. Yeah, so thanks for the introduction to it all. Yeah, I really like your approach of just trying to make yourself the most effective that you can be with your skills, rather than just doing something just because you could be good at it, like being a pianist or whatever. Like, I think it's a very entrepreneurial attitude. I have similar feelings of, I don't really like having a job because I feel that someone else could already do that. And like, I feel like I have to go and invent something because of I'm always having too many ideas. What's the point of using my ideas to do something that someone else can do? It makes no sense. And then also your approach to aging. I've had this conversation with people whereby like I used to kind of like asking people if they want to die or not. And then so many people would say yes. And it was just, I could never like kind of understand why people would do that. Because it's like, tomorrow, do you want to be able to not walk up the stairs? No, you want to be able to walk up the stairs and things like that. And it just seems so fundamentally short-sighted to think that in like 30 years time, you'll want to be able to like need someone to help you go to the toilet and these kind of things and the whole aging thing. So I've always loved your work because it's so in touch with like just sensible thinking about it.
Well, thank you. I mean, it was always obvious to me, but you're quite right. It's something that's not obvious to most people, even now. And a lot of what I had to learn over the years, as I became quite high profile and started doing a lot of public speaking, a lot of interviews and so on, was how to find the right pressure points, the right language to get through this irrationality. And of course, the very first thing to emphasize there is that it's always got to be about health, because people really are very unsure whether they want to live a long time. In order to form an opinion about how long you want to live, you have to make a vast number of assumptions about what your life is going to be like in the distant future, which is, of course, completely impossible. So it is, you know, I believe it's completely crazy to have an opinion at all, positive or negative, about how long one wants to live. But it's a very different matter to have an opinion about whether one expects ever to want to get sick. You know, and so if this is all about simply healthcare, and if one recognizes that longevity is simply a side effect of not getting sick, then the argument becomes a great deal easier to make. And that's why I emphasize that so much.
Yeah, it's a good philosophy, isn't it? It's kind of hard trying to work out what people will respond to or not. And especially when you've got like something that seems very logical. Same as like the whole issue with when we first developed like genetic engineering, like for plants, and like the whole EU just banned it. And you're like, oh, but it would like massively improve the world and and all these things that could have been good, but it just sort of got branded as like this terrible thing. Well,
yeah, actually, it's even worse than that, because when we've had these things like, for example, the unpopularity of genetically modified crops, or for that matter, other things like, you know, cloning in the US, you know, creating nuclear transfer. Well, you know, these specific technologies, one can always say, well, you know, is this safe, or is it safe yet? And, you know, should we slow down and things like that? And these arguments are generally, you know, not stupid. They've generally got some basis in fact. And of course, there is a wide spectrum of opinion in each of these cases with regard to how cautious one ought to be, at what point the risks are reduced enough that the cost-benefit ratio is positive. But in our case, with aging, it's worse than that, because we're not even talking about a specific technology. The concerns and, you know, hesitation and ambivalence that exist with regard to bringing aging under medical control is irrespective of the technology. You know, it's just, you know, even in the case where the medicine works, people are uncertain whether they want it. And, you know, that's much more crazy.
Yeah, definitely. It's a hard one. On this subject of like hot topic things, what do you think about the future of genetic engineering for humans, and possibly like the research that's going into like CRISPR and improving like the genome? So not just like selecting people that are like blonde and tall, but like literally making them like smarter and muscular or whatever you want as a human.
Well, for sure, there are all manner of reasons why we would want to develop technologies that allow us to modify the human genome. The most obvious and uncontroversial ones are with regard to congenital diseases, of course, things that make kids sick at a young age and the result of having inherited the wrong genes from their parents. These things, it's very practical to suppose that we could actually eliminate them using methods that are, if not already ready for prime time, at least pretty close to it. CRISPR itself, when it was first developed 6 or 7 years ago, was definitely not very safe. It had a high error rate, but people have been working very successfully to reduce that. And it's now got to the point where we are pretty close, I would say, to being able to do this. However, one thing that is very important to emphasize in relation to aging is that we have 2 ways to go about modifying the genome of people. One way is called germline gene therapy, which means taking a fertilized egg or even the gametes that are going to become the fertilized egg and modifying them so that the individual has the genetic modification right from conception, or at least right from implantation. And the other approach is to do what's called somatic gene therapy, which would take someone who's already alive and been born and perhaps is already an adult and modify the genomes of, or at least some respectable subset of the cells in that person. Now, clearly, the latter alternative, somatic gene therapy, is far more challenging technologically, and everyone knows it. And so far, the only real work that's been done in earnest on human somatic gene therapy is with regard to specific conditions that, for whatever reason, can be treated even if you successfully modify only a very small proportion of the cells in the relevant tissue. So, for example, there are certain metabolic diseases which can be very, very effectively alleviated just by restoring a mutant function of, let's say, 1% of the cells in the liver, because those cells then take over, basically. But that's not true for most aspects of congenital diseases, and that's why gene therapy is by no means ready for prime time for most things. Now, in the case of aging, something that a lot of people overlook is that we really don't need to worry about that, because by definition, aging is not bad for you until you're 50 or more, right? And so even though somatic gene therapy is ridiculously more challenging, very much more challenging technically than germline gene therapy, nevertheless, we've got 50 more years for a given individual, right, to benefit from additional advances, not only in terms of how successfully we can do somatic gene therapy, but also in terms of what genetic modification we would actually seek to bring about, whether insertion of a new gene or whatever. So I believe that germline gene therapy is very unlikely ever to have any real justification in relation to alleviating aging, the health problems of late life.
Okay, interesting. So yeah, when I was studying my degree, I did a degree in biology. I thought somatic gene therapy was kind of coming around the corner. Like they've been talking about potentially being able to use it in cystic fibrosis, and like studies in mice where they've had like colorblind ones which had restored to color vision using kind of the gene therapy. But I don't know if it's actually really developed that much further in like the last sort of 8 years.
It certainly has. Plenty of people are working on it because they know that the ultimate reward, if once we can get it working well enough, is enormous. And yeah, I mean, progress is being made, slow but steady, and I'm sure that will continue. But of course, the issue here is, as always, that doing something in mice, you could get, people aren't too worried if 10% of the mice die as a result of the therapy. Whereas if that happens, then you're in a bit of trouble.
Yeah, there's a lot more side effects in the human genome because there's just so many other things going on. It's a lot more complex.
No, it's not that there are more side effects. It's just that we care a great deal more about the magnitude of the side effects.
Yeah. Okay. I'll take your word for it. You're slightly more well-researched than me.
Well, I mean, this isn't really a research matter. This is simply a sociology matter.
Yeah.
The fact is, mice die in experiments all the time, and nobody really cares.
Yeah, definitely.
Whereas in the late 1990s, and this is specifically about gene therapy, there was a clinical trial coordinated by the University of Pennsylvania And one teenager, who shouldn't actually really have been in the trial, it was a kind of a mistake, one teenager died from anaphylactic shock as a result of gene therapy that he was given. And that caused such an outcry over, inadequacy of rigor in the conduct of the trials, that all clinical trials for all gene therapy were basically completely closed down for at least a year, worldwide.
Wow.
Now, that, of course, has had knock-on effects in terms of delaying progress in this area.
Yeah, and potentially millions of people now die or something because of this. But
well, you're absolutely right.
Yeah,
I mean, but this is the nature of society's risk aversion.
yeah.
Bad news makes a lot more headlines than the absence of good news.
Yeah. Same as like AI and driving cars, as in there's so much regulation around it. If like one car kills someone, it's like huge news, whereas like there's people dying every day, like every minute probably in like the current scenario. And yeah,
it's exactly the same. You're quite right.
It's a bit ridiculous. But yeah, it's a fundamental human problem of just not liking to take risks and do things that are different and just accept things as they are, at least. Okay. So a bit of a change of pace. So back into aging then. What do you think we should like explain, and what are the main ways of aging? Because you kind of go into this in a few places, like the 7 sort of types of aging and stuff. Could you explain that a bit better?
Sure. So the fundamental concept that I introduced nearly 20 years ago now, and that, as I mentioned earlier, was initially viewed as very heretical, but is now very much mainstream, was that the most common sense and most practical approach to keeping people healthy late in life was simply to repair the damage that the body does to itself throughout life, not necessarily perfectly, but well enough so that the overall amount of damage that remains in the body is within the capacity of the body to tolerate. And this was basically founded on a more rigorous definition, a more simple and clear definition of aging than ones that other biologists had historically been using. I define aging very straightforwardly as the lifelong, even starting before we're born, the lifelong accumulation of various types of molecular and cellular change to the body's structure and function that are generated by the normal functioning of the human body. In other words, they are side effects of normal metabolism. And the body is set up to tolerate a certain amount of those changes, but they continue to accumulate throughout life, and eventually their abundance exceeds what the body is set up to tolerate. And that's why we get sick late in life, and eventually we die because there's so much of that damage. This is a really, demystifying definition. There's nothing, wishy-washy about it. And if you've got that in place, then first of all, it's easy to see that there's no way we can actually cure the so-called diseases of old age, like Alzheimer's, because they are side effects of being alive, and we don't want to cure being alive. And secondly, it makes it clear that we're not really going to have any success in terms of just slowing down the rate at which damage is created. In other words, making metabolism run more cleanly, which is essentially what gerontologists had historically been trying to do for the previous decades before I came along. Because that too involves essentially manipulating a system that we don't understand very well, namely our own metabolism. Whereas repairing damage sidesteps all of our ignorance and all of the complexity that is involved. We don't need to slow down the accumulation of damage, which means we don't need to actually understand how that damage is generated in the first place. We can just keep the overall level of damage down to a level where it doesn't cause us to get sick. And that, of course, means that we also don't need to understand the details of how having too much damage does make us sick. And then the only question remains, what is this damage that we've got to repair? Because we've got to characterize it, of course, even if we don't have to understand the mechanisms whereby it is created and whereby it's bad for us, we still have to know what it is in order to be able to design ways to eliminate it. And so my first real attempt to do this just split aging, the types of damage in aging, into a very small number of categories, just 7 categories, for each of which there was a generic approach to fixing it, approach to actually doing the damage repair. And that classification has very much stood the test of time. We still use the same thing. And furthermore, the generic approaches to repairing the damage have also stood the test of time. The approaches, even though they were very conceptual early on, and there was a huge amount to do to actually implement them. Nevertheless, they have not encountered any barriers, and we have made huge progress against all of them. So that's all very splendid. And now, as I say, people are reinventing this idea and kind of pretending it's original, and there are quite a few recapitulations of this concept that have come out in the past 5 or 6 years. Some of them just split aging into 9 categories or 6 or 8, but it's all exactly the same idea. It's not as if anyone has come up with some new type of damage that did not fit within my original classification. So that's why I say that now this idea is totally mainstream. And, you know, I could spend the next 10 minutes listing all the things and how to fix them. You can look that up on YouTube anyway.
Yeah, exactly. Cool. Yeah, thanks for explaining the concept, though. It's kind of quite interesting. So then, what would you say? There's something else I wanted to ask before I jump into the next thing. Yeah. So, what would you say are like the biggest things that sort of a normal human can do up front to sort of help combat aging? As in, what could I change something in my diet, or should I stop living in London because of air pollution, things like these?
Yeah, a lot of people ask this question, and unfortunately the boring answer is that there's really nothing that one can do over and above just, you know, living the way your mother told you to, and not smoking and not getting seriously overweight, and, you know, having a reasonably varied, balanced diet. The effect of pollution, for example, is, you know, really very negligible. I mean, of course, there are exceptions. You can be living in an extremely polluted place, like, you know, Peking, but the level of pollution that you'll have in most major Western cities, it causes damage in the body only at a far smaller rate than other things that are intrinsic to being alive. So, I mean, by far the single worst thing that you're doing for yourself right now in terms of causing damage to be generated is breathing. Breathing is spectacularly bad for you because the way that the body uses oxygen in cells in order to extract energy from nutrients is a very hairy chemical process that generates toxic side byproducts called free radicals, which cause damage of all manner of different types. But breathing is rather, you know, non-negotiable. So, you know, that's the thing. That's the way to be thinking about it. And that again explains why we really have no hope of actually modifying the body so that it makes damage at a slower rate, and therefore we should be intervening one step further along the road and actually repairing the damage and living with the fact that the damage is going to be generated. So yeah, in terms of lifestyle, you know, like obviously do as much exercise as you need to keep a good BMI and so on. You know, different people need different amounts of exercise.
Yeah.
Same with
crazy
really,
exercise bad.
But really, so that means that the way to ask the question is what can you do is to ignore the obviously bad things that you can do that can significantly shorten your life, and to ask, well, okay, how much might you be able to lengthen your life, your healthy life, by doing everything absolutely right, relative to just, you know, essentially doing what your mother said, but not really thinking about it beyond that. And the answer is, it's negligible. It's absolutely tiny, if anything, how much difference you can make that way.
Yeah.
Which of course brings me to the real answer to the question, what can you do? And the real answer arises not only from looking at how long you're going to be able to extend your life, but also whether you can make any difference to how soon therapies will come along that will be more effective than anything that exists today. And of course, people have got ways to influence that. And you're doing one of them right now. You're putting me on air and getting me to explain those things to people, and that will, you know, cumulatively, the reason I do so much media, that cumulatively raises people's awareness of this and their understanding that this research has some chance of actually succeeding in the foreseeable future. And as such, it raises people's enthusiasm for actually spending money to make it happen sooner rather than later. Whether it's donating to SENS Research Foundation, whether it's advocating for public spending to happen, you know, whether it's investing in a startup company that's in this space, all those things.
That's cool. Yeah, I really like the concept of if you can keep yourself alive at the rate that you can keep extending your life, you just sort of can live infinitely, technically speaking. And so, yeah, if we can keep ourselves alive long enough to fund you to do the best work, to then keep us alive longer and keep it going, then good times. But on this topic, have you looked much into like fasting protocols and what those do? Because they've there's been like a lot of evidence that it helps extend your life a bit. Is that like another thing you could do to kind of just buy yourself a bit more time?
Yeah, so people obviously are interested in this, and certainly it's a great way to live a fair bit longer if you're a mouse. But
Yeah.
unfortunately, it's very apparent for a long, long time that the benefit, the magnitude of the benefit that is experienced from any kind of fasting or what are called calorie restriction mimetics, which are drugs that trick the body into thinking it's fasting when it isn't, the benefit that you get for longer lived species is much less than for shorter lived species. So little nematode worms that are used in the laboratory and normally live about 3 weeks, you can multiply their longevity by a factor of about 5 by just starving them in just the right way at the right time of their life cycle. But you won't get 5 for mice. You'll only get like 1.5, a factor of 50% additional lifespan. Now that's still plenty, but of course the same thing applies as you go up the chain. So for example, there was an experiment done about 20 years ago on Labradors that normally live maybe 10 or 11 years, and they only got 10% increase in lifespan. And then there were a couple of very, very long and expensive experiments done on monkeys that reported a few years ago, and they got, a few percent if you're lucky. So it's not looking very promising. However, I will say that doesn't mean that I'm not in favor of such measures. I think that they do have definite health benefits, especially for those people who are not living an ideal lifestyle in the first place. People who just really like going to McDonald's. This may actually considerably help. And so anything that improves health,
definitely.
Yeah.
Sorry.
Anything that prevents premature ill health is obviously beneficial, and I think therefore this research is very valuable.
Okay, cool. But it's not so much the type of research that you're focusing on for like major longevity in terms of repairing things as it's going along.
That's right. It's not the Holy Grail.
Okay, but it might help you like a tiny bit to get there and wouldn't really hurt to get involved in.
Right.
Okay, cool. So I'll carry on. Do you follow anything like microfasting?
Well, I'm lucky. I can do basically what I like and nothing ever happens. And I don't even need to do much exercise.
So I was going to ask, because then you don't look your age exactly. So are you following a bunch of amazing tips? But it sounds like you're not. You're just being like
I'm just well built. Yeah, I'm just well built. I mean, some people say I look older than I could just because the beard makes me look older. But I don't know. I don't really care.
It's a bit of a Gandalf look, but then like the rest of you doesn't really look kind of old, as in, yeah, I expect it to be like more grey and less hair on top and things.
Yeah, I care more about how I feel and how I function rather than how I look. But anyway, keep going.
Yeah, it's good to hear. So this has been fascinating. Then I love how you've then actually been able to take what you're interested in and then turn it into a functioning business and like have SENS going on. So how did you actually approach making that happen?
So basically what I did was I was kind of reasonably active online even in the 90s before I had the key idea of SENS. And so, there was a certain amount of, a small community of enthusiasts and of course some experts who were involved there. And of course I also was going to professional conferences and meeting the top people in the field. And then when I had this idea and I started putting it out there, of course, I was explaining it as best I could to people, and more people were hearing about it, and I was getting invited to more and more conferences. And in around 2002, I was approached by a businessman from Virginia who was very keen on this and thought that what I was saying made sense. And he had the knowledge and the skills to actually set up a charity, what's called a 501c3 in the US, a public charity, for the purpose of promoting all of this. So we did that. And initially we didn't have any money, of course, so we couldn't do research. But we decided that what we could do in the near term was to raise the public profile of this whole research area in a way that will allow it to be funded better in the longer term. And so we created things called the Methuselah Mouse Prizes, which were essentially just competitions that said, we'll give you some money if you beat the mouse world record and for lifespan. And the idea was that the money we would give would be some proportion of the money that people had given us to put into the prize pot. So we were seeking donations for that. And the way it worked was that the proportion of the prize pot that you would receive if you broke the record would be dependent on how much you beat the previous record by. And that meant that we were able to actually put away a bunch of money that we could be very sure we would never have to actually spend, because no one would beat the previous record by, let's say, a factor of 10. So that meant that eventually, around 2005, we were able to start actually doing research, actually funding research, PhD students in actual university labs. Just a couple, but still better than nothing. And that went really well. After a couple of years, we started getting more money in. Our first major donor was a guy named Peter Thiel, who's quite well known as a radical and important supporter of new technology. He started giving us around $1 million a year in 2006. And after a couple more years, we decided that actually the mission would be best served if we split the foundation in two and had the Methuselah Foundation carry on doing what it was created for, namely the publicity and these prizes and so on, while we had a new foundation, SENS Research Foundation, that was focusing on doing the research. The idea was basically that that would allow the messaging to be more attuned to the activity. You know, you have to be very superficial and glitzy and populist if you're trying to promote prizes, and that doesn't go down so well with research. So it worked very nicely. So the two foundations have both been very successful since that time.
Cool. Yeah, that's pretty fascinating. And then how did you go about like finding the right sort of partners to work on it with you and growing a team? And then, because it's not like a
sure. In terms of the scientists, that wasn't nearly so hard. So first of all, in terms of professors that we might fund to do work in their universities or institutes, that's really easy. You basically you have a project and you think that this particular professor is the world's best person to work on it because of what they've done before. You just go and contact him. In many cases, I would have known this person already personally from conferences. And I would say, well, okay, I'd like you to do this, please. And he'll say, well, yeah, no, I'd prefer to do that. And I'll say, well, if you do this, I'll pay you. And he said, all right. So that's actually fairly easy. And then for youngsters, it's also not so bad. I mean, this is a large part of the reason why we set up the foundation in the Bay Area, is that, this is the world's most largest collection of visionaries, of people who are keen to aim high. And that certainly includes people in biology. And of course, aiming high in biology basically means working on aging. It's pretty easy to persuade people that that's the thing they ought to be doing if that's the kind of person they are. So we, again, found it pretty easy to attract very, very talented youngsters into all of this. In fact, early on, we would never even put out job applications. We would basically just let people come to us and say, listen, I really want to work for you, and we would get really, really good people that way.
Oh, nice. Oh, those signs. I guess it's the whole theory of if you're working on something that's really interesting and important, that you don't have to. It's not such a problem to get people to come and work for you and like see your vision. If you've got like a really clear vision, like people want to get behind it, and that's sort of the hard part done.
That's right, especially for this particular one. I mean, especially with this particular one, people who have that kind of mentality tend to understand the logic that you and I understand about the importance of aging and the way to go about it far more quickly than most people do.
Well, hopefully everyone listening to the podcast will get it. And one thing actually I was thinking about, I was trying to get David Attenborough on the podcast, which is pretty ambitious, but I was going to a thing with him anyway. So I was like, oh, well, I'll send him a letter anyway. But I was looking at his age, and I realized that between us, we're like 120 collectively. And I was like, holy crap, that's a lot of years. And like 4/5 of that is him. And like, I'm like literally a quarter of his age, which means that it's like me talking to an 8-year-old right now, which is ridiculous. And that I have so much more experience than an 8-year-old, but he must have like fathomably huge more experience than me as a 28-year-old. And was like, wow. So an old person actually must be so much massively smarter, and like must have so many like mental models and thoughts and just so much wisdom that I haven't even conceived of. And so being able to keep someone like David Attenborough alive for like another 50, 100 years is actually hugely important. And ending things like aging is actually a lot more important than I realized, as well as just the fact that I don't really want to die. And
well, that's completely correct. And of course, you're really understating the thing, because number one, people in their 90s or 80s are not as able to make use of the wisdom that they've accumulated over the years, because their brains are gradually going downhill. Of course, some people faster than others. But secondly, even the people who have actually not achieved anything particularly notable in their lives so far, you know, that's just because they didn't get lucky, you know, in terms of having the right education or being in the place at the right time. And there's no reason why people like that should not be the next David Attenborough, even if they only start to try to get into that field late in life, just as long as they stay both mentally and physically youthful thereafter.
Yeah, there's two really cool points. 'Cause, yeah, we're used to the perception of old people being a bit like dumb and not that good and forgetful, and that's just because if we haven't solved the thing, so that they have like so much more potential that's sort of being covered by the process of aging, which is the stupid thing. And then as you get older, you just get so much better at being able to do things and execute. So it makes sense to that people would be able to do so much better as they age, even if they hadn't done stuff before. Have you thought about like I was thinking about, you know, the trolley problem of a car that maybe has to kill like one old person or like 5 1-year-olds or something. And I was thinking like, well, technically, if it's going to kill 1 50-year-old or like 5 1-year-olds, it's sort of better to kill the 1-year-olds in terms of they're not going to add anything to society for the next 20 years and just like take resources and need to be taught stuff. Whereas like the 50-year-old has got like so much education and value in their brain, and suddenly it's like, on that theory, it's like it's much better to keep the 50-year-old alive, because of next year he could like solve a bunch of problems and stop loads of people from dying, whereas the 1-year-olds are going to do nothing for ages. And obviously there's lots of other counter arguments, but it was just like one kind of philosophy that you're like, actually, yeah, maybe old people are quite useful.
Well, that's true. Yes, exactly. But of course, there's many different philosophical positions on that. One can say, you know, the young people should be saved because they've got more to lose, or because they have not yet had the benefit of living a long time and enjoy and having you know, a lot of enjoyment of life so far. You know, honestly, you know, the main thing to focus on is that in the real world, it's not a zero-sum game. You don't have to make that choice.
Definitely, it's sort of a bit of a silly thing, but I guess it was nice to sort of realize just like the value of age, at least from that, even if like the rest of it doesn't really matter. Okay, cool. Back to the general things. So in your own life, like, have you had any kind of changes in how you think besides your theories on aging and like AI research that you're doing, as in fundamental like approaches to where you've done things that you sort of were doing things wrong in life that was causing you problems, but now you sort of like, oh wow, I was being a bit stupid, this is how I should do it?
Not really, to be honest. I have I've not had any real big change of direction that way. I mean, even the case where I switched fields from computer science to biology, that was not as a result of thinking I was somehow being stupid or being making a wrong choice in how to use what I knew. It was just a case of something that I honestly didn't know. So the only thing that I could say was stupid was that I had, until my late 20s, just not bothered to do the experiment of asking people whether they thought that aging was the world's most important problem. And therefore I didn't find out until I accidentally found out that actually hardly anybody did think that way, and therefore I had essentially made the wrong choice early on in choosing a career. However, even that is, you know, questionable, because I definitely benefited a lot in the early days of my biology career from having learnt my research skills in a completely different field. And this is by no means unusual. It's quite clear that when people switch fields, they very often do really good things in their new field because they've got the skill set to work on really hard problems, which is a very transferable skill, but they're not encumbered by the conventional wisdom that everybody else in the field has.
Yeah, definitely. Or you can bring something to the field that makes it take off. So if you've done a career in business and then you go into science, you can actually like turn that into a business and make it happen more than if you just do some research kind of thing. There's lots of like, bringing different skills together. Okay, so what do you think you'd have done if you'd been born like 100 years ago?
Sometimes I feel like I was. Honestly, I have no idea. I mean, you know, that means being born, let's say, 50 years earlier than I actually was.
Mm.
If I had ended up thinking about aging at all, then I don't know whether I would have been able to put two and two together in the same way, but probably not. Because if I go back to the year 2000, the way that I was able to convince myself that this comprehensive damage repair approach actually had legs was because of putting together a bunch of pieces of the jigsaw, so to speak, that had really only been developed in the previous few years. You know, if you go back to the first paper that I wrote in that area in 2002, you can see that some of the key references were from 1999 or from 1996. So really, the substrate wasn't there. I guess it's the same with artificial intelligence. I mean, the term artificial intelligence was first coined in the 1950s, but actually figuring out how to research it was essentially nobody had the faintest idea what to do.
Yeah, yeah, because it's definitely that completely different time in terms of computers and things. Okay,
I cannot overstate the importance of being in the right place at the right time.
Yeah,
you know, I've become obviously a prominent person in this particular field, but you know, I'm certainly not taking credit for that in the sense of it being because I'm exceptionally smart or exceptionally charismatic or anything, or exceptionally determined. I mean, I'm fairly all of those things, but really, the biggest contributor, the biggest component of this is I was fantastically lucky to be, you know, to have the right skills and meet the right people at the right time.
Yeah, it's a combination of luck and having all the skills and being able to execute on the luck that life has just put in front of you, kind of thing. But it's a humble opinion to realize that it's not entirely because you're amazing, although you are pretty amazing in my own personal opinion. So yes, anyway, back to me asking stupid questions. What do you think is going to be the biggest change in like 10 years time in the future?
You mean in this field?
Yeah, in the more aging field. What do you think is going to be coming soon?
Yeah, I think within the next 10 years, with pretty high probability, like I'm going to say 80%, we will have reached the threshold of research that I historically have called robust mouse rejuvenation. In other words, we will very probably be able to take a bunch of mice that are already middle-aged before we've done anything to them at all, genetic or dietary or pharmacological or anything, and then we'll be able to throw a whole bunch of therapies at them and double or maybe even treble their remaining lifespan. So a typical mouse, long-lived strain, would live maybe 2.5 years. We would take these mice at the age of, let's say, 1.5 and get them to live on average to 3.5 or 4 instead of only 2.5. Cool. I believe that is a very, very important milestone to be looking at, because what it's going to do is it's going to be enough to persuade my colleagues, my senior research colleagues, to actually publicly say, yeah, we're getting there. It's only a matter of time before we can actually bring aging under comprehensive medical control. You see, at the moment, we still have the same problem in terms of public perception and public statements that we had when I got going. Namely, that out of the entire universe of senior influential experts in this area, which is a small number of people, like a dozen, you know, people who actually know their stuff and also are willing to actually go on camera a lot, right? Out of those people, I am the only one who has managed to become prominent in this field without having to effectively sell my soul to peer review. In other words, having to get into a position where the bulk of my research depends on getting grant applications funded by the government. When you're in that position, the very, very most important thing you have to do is avoid giving your colleagues reasons not to fund you. And your colleagues are really looking for reasons not to fund you because they've only got like 10% as much money as they would need to fund everybody who's asking for it. So they're looking for reasons to say no. And if they can accuse you of being in the habit of saying irresponsible things on camera, then you won't get your money. So all of my senior colleagues are very, very, very cautious in what they say to the general public. And I'm the only one who doesn't need to be. But eventually, when we get to this point of robust mouse rejuvenation, that won't be such a problem. It will become so idiotic to say, yeah, we still don't have a clue, when it's demonstrated that we're doing that much in mice. It will become so idiotic that people will be willing to go out and actually say, yeah, we're getting there.
Cool. Yeah, well, that sounds like a really exciting turning point if we reach it. So would you say that's kind of like the thing you're most excited for, like the sort of the goal you're really working towards at the moment?
Yes, that is the goal. In fact, it's the goal I've always been working towards. I believe that at the end of the day, this problem of aging will not be solved by one person or one organization. It will be a collective effort, because it's a divide and conquer approach, let's face it, developing good ways to get rid of all these types of damage. And that will happen fastest when we have a wide variety of people, dedicated and skilled people, working on it. So my goal is, and has always been, to grow this movement to a sufficient point that I become unnecessary. That there are people in the movement, in the field, who are better than me at each of the things that I'm good at. And then I will retreat into glorious obscurity, and you'll never find my email address. And my job, essentially, my job will have been done.
Nice. So you'll won't retire peacefully, because you won't need to retire, because you'll be able to live forever and just go take on an entirely new thing. Hypothetically.
That's right. Or maybe I'll just have a vacation for a little while.
Yeah. So yeah, what do you like on work-life balance? And do you say you maybe work a little bit too much? Or
well, you see, for someone like myself who is really fulfilled by their work, there's not really any such thing as work. When I talk about the problem of work and the reason why I worked in artificial intelligence research originally, the way I describe work is stuff that you spend a lot of your time doing, but you wouldn't unless you were being paid for it. And in my case, that's not the situation. I essentially don't have a job already.
Yeah, nice. So you're running around having fun, basically.
Yeah, and not getting enough sleep, it must be said, but
yeah. That's not good for aging, apparently.
But I figure I'm hastening the defeat of aging by a larger amount than.
Yeah. So it's worth taking a few planes if you're like massively reducing the amount of carbon being released, kind of thing, because you're doing something useful.
Indeed.
But it's a bit of a sacrifice on your part, because it's just your own personal age, whereas you're kind of helping everyone's.
I suppose, but it doesn't feel that way.
Yeah, well, thank you very much. It's nice to hear that you're working on it. What is the kindest thing that someone's ever done for you? Kindest? Yes.
That's a hard one, actually. People do kind things to me all the time. One of the things that makes my life easier is that complete strangers come up to me in the street and say they're really keen on my work and they think it's really important and all that. So I have a vast amount of positive feedback all the time, and people don't have to do that. So I regard it as an act of kindness to actually come and give me some of that. And actually, the people I really look up to in this movement are the foot soldiers, the other people who are just as dedicated as me. They work just as hard. And they don't get any of that because nobody knows their faces. So, yeah, people are kind to me all the time.
Cool. Well, it's good to hear that. Really makes you happy. And I hope this encourages anyone who does see you to just run up and say hi and make you feel good. And yeah, I hope that I've made you happy, because I'm really enjoying your work and this conversation. So thanks a lot for it and all the work you're doing. And then is there anything that you would like me to do for you, or any of the listeners that would help?
Well, sure. I mean, the first thing, obviously, is to ensure that everybody has a link to our website, which is a very comprehensive account of what we do and indeed what other people do, latest views and so on. And it also it's written for every audience. There's plenty there for complete novices as well as for absolute experts. There's obviously a contact form as well. If there's any questions that one has that one actually thinks we could answer, you can write and we get back to you pretty promptly. Oh, and of course, there's also a nice big friendly donate button.
Yeah. Okay. Donate. Go have a look. Find out more about it. Okay. Cool. Yeah. Is anything else you think I haven't asked that you'd like to talk about, or any questions for me?
Not really. No. I think what you've covered here is you've covered enough about the science so that we've been able to see that this is a realistic prospect in the foreseeable future, and also enough about the social context to understand why the concerns that people have are irrational, and indeed perhaps why they persist despite being irrational, essentially, for me, it's all about just people's fear of getting their hopes up and knowing that people have been wrong about the defeat of aging right through the history of civilization, and maybe they don't want to really believe it until they see it.
Definitely. Okay, cool. And learn a bit about you and how you approach doing all these things, which has been quite fascinating, and mindsets behind it, which is where the podcast angle comes from. Cool. All right. Then, yeah, any singular parting quote you want to end on?
No, I think that's it. I think, just thank you for having me on the show, and thank you to all the listeners for listening and getting right through your podcast. And I very much hope that some of your listeners will make contributions in the future, whether financial or any other kind of contribution.
Sure thing. Okay. Well, thanks so much.